Now that we have a basic sim, let's go over some of the most relevant parameters that we have inside the PyroSim to help us control how the simulation actually develops. So I'm gonna stop the simulation and dive inside. Okay, so it's in here on the Pyro solver that we're gonna be spending a bit longer. What we have here is the result of the default settings, and the default settings in terms of simulation has, let's start here on the simulation parameters. Now, the time scale, as it says, and it's the same for particles, it just allows you to slow things down, slow the development of the simulation down, or accelerate the development of the simulation. And then you have temperature diffusion, cooling rate, I'm going to skip viscosity, and buoyancy lift. Now, right now, as you know, we don't have any velocity on our simulation, but nonetheless, the smoke still continues to rise. The reason why it's rising is because here on the volume source, we're not only feeding the density in, we're actually feeding the temperature as well. We created our source with density and temperature, and those two are being added to the simulation. As the smoke heats up with the temperature, it's going to rise. If we scale the temperature to 0, for instance, we should see that even though the smoke is being added, nothing's happening. So it doesn't rise because the temperature is at 0. Okay, it stays in the same place. So let's put this back to 1. The buoyancy lift is the parameter that you're going to be using to control how fast the simulation is going to rise based on the temperature. Right now it's rising pretty fast, as you can see, but if you lower that value to, let's say, 1, it's not gonna rise as fast. And if you want it to rise faster, just increase this to, let's say, 10, and it's gonna rise much faster. Regarding the temperature, there are other parameters here that are very, very relevant. Let me put this back to the 5, which is a default. Now, as you can imagine, if this is going to react to the temperature, these two parameters which affect how the temperature is actually being developed or how the temperature is being simulated on how the temperature evolves during the simulation, they're also very relevant to control if it rises more, if it expands more, and so on and so forth. Here, the cooling rate determines how fast the temperature is going to be decreasing. So we're adding temperature here, but when it rises, it starts to decrease the temperature. It starts to cool down. So that's the cooling rate. You can see that if we set the cooling rate to 0.01 or something very, very slow, it's going to continue rising pretty much at the same speed. Right now it's dissipating, but that's also one of the defaults that you have here on the shape. Let's turn off the dissipation for now. Okay, so it keeps rising pretty much at the same speed. While if we put this to, let's say, 0.95, it's going to cool off and slow down much faster. So this is something important to keep in mind. The temperature diffusion is an effect of blurring the simulation of the diffusion. I'm going to put this back to the default value. These are all defaults, and I'm going to show you some other stuff that's also useful when you're kind of figuring out how things work and what's actually happening. If you go here to your smoke object, you have a visualization tab here, and we can turn on the temperature. I'm going to keep the density on. And when we look at the temperature, this is what's going to be showing. Let's hide the density for now. As you can see, this is the warmer areas. We're just looking at a slice of the grid. Okay. And this is being displayed as a black body, which is how humans perceive heat. So black areas are cold and yellow areas are hot. Then you have white, then you have blue, which is actually even hotter. But yeah, this is how you see the dispersion of the temperature. Whenever we send over a ring, we add some temperature, it heats up and it starts heating, but it cools down. If we don't have that much, if here on the pyro solver we don't have as much temperature diffusion, diffusion is going to act as a blur, as a way of diffusing the temperature all around the voxels. If we lower this quite a lot, you'll see that the temperature, it doesn't scatter as much. It's more contained. Okay, we have more of this type of detail, small detail. Okay, and this will give you a different look on the simulation. Let's go here to the smoke solver, turn off the temperature, and you'll see we get a completely different look. It's kind of, it's a nice way of getting more detail, more spirals, more vortexes, more vortices going on the simulation. Okay, and this combined with the temperature, the diffuse, the cooling rate, you can really make sure that this goes on for a really long time. Let's say we have a much smaller cooling rate, and you'll see that it might not be as noticeable, but the temperature continues to develop, and it's warmer for a lot more time, and there's more interaction between the rings that follow. Okay, now I'm gonna put these back to the default values, 0.5, 0.75, and this is what we have.